everyone. As we've gone through the separation that is being carried out at the double deck screen, I made mention of key things, and one of which was the separation that has to do with bringing certain materials to the ball mill. I said materials that are medium in size that passes through the first deck of the screen that doesn't have the opportunity to pass through the lower deck because of size needs to come to the ball mill for further grinding and reduction of size before being sent to the hydrocyclone. We're actually at the top of the ball mill where the feed to the ball mill is being initiated, and it passes through the transfer chute. This chute is wherein the feed is being introduced that goes to the ball mill, and it's being carried out through by conveyor 18. It's the one that feeds this ball mill. We have our wedge that does the lifting of the steel balls, the charging media. Here, the difference between here and the crusher is you have blowbars within the crusher and impact plates. Here, you need a charging media that you put inside the ball mill to carry out the grinding. It's that horizontal rotation of the ball mill that causes the media to rotate on top of each other, thereby squeezing the rock particles, the smaller size, or particles, and further reduce them in size. I actually have an opportunity of showing you one of the charging media. It's a steel ball. The charging media can either be ceramic balls or steel balls, but we in our operation here actually deal with steel balls, and this is a 60mm size steel ball. We need to charge the ball mill on a continuous basis until it gets up to an indicator of like a 600 kilowatts. That is the power and amperage rating that will give us the power. So what we normally do, there are basic responsibilities you have to do here. You need not overcharge, because if you overcharge, it means the steel balls, this media, will continue to grind on top of each other, thereby causing wear. So it means you are not producing much. And you need not undercharge, because if you undercharge, you don't have much of the charging media inside, and you ensure that the feed to the ball mill surpasses or overcomes the charging media. It means it will buffer, it will cover the charging media. It means effective grinding will not occur. The feed rate and the charging rate have to be a par, or the charging rate slightly gets above the feed rate, thereby ensuring a powerful and more efficient grinding. And we also need to control the amount of volume of water that comes into the ball mill, because we need to increase the rate of friction that is within the ball mill so that we have proper grinding. But if there's too much of water, you'll note that we lessen the friction rate, and that will create a lot of inefficiency and ineffectiveness in grinding. And we want to have fine ore size materials. So it's a key responsibility that we always need to take care of while carrying out our charging. So we are at the top, like I said, this is the chute where the feed to the ball mill is being introduced, and this is where also we do the charging, after lifting the steel balls from down. You can see down, we see you have a set of drums. You can see them. We have to use our wedge to actually lift those drums, get them at the top. We start the charging of the steel balls through the chute here as well. We do our charging here, ensure that it goes into the ball mill, and as it is rotating, it's a rotational, horizontal rotating equipment that allows the balls to roll on top of each other, thereby carrying out an effective grinding. So having talked about the top, it pleases me to actually go to the down or bottom of the ball mill itself for you to see certain components and actually see how the process is being done within the ball mill. We'll now take a walk, just a short while, to get to the ball mill proper. We're heading our way to the ball mill, having seen the chute at the top. Now we have the pleasure of actually meeting a lot of things that will interest you. Okay. You see the chute trolley. This is a trolley. It carries the chute. This is the trolley. It actually carries the chute that helps us to get the feed into the ball mill. And this first part here of the ball mill is known as the tronion, the feed tronion. This is the feed tronion. This part of the ball mill is the feed tronion, through which the feed from the chute is introduced into the ball mill. You have the mill itself, as you can see. You have the mill itself, as you can see it. Yeah. We have a gearbox arrangement system. We have a pinion bearings. This is the pinion bearing area. Of course, this whole section is the pinion bearing area. We have an engine drive. Here is the engine drive. Here is the engine drive. Before the ball mill is being started, you can see the engine drive here. Before the ball mill is being started, you actually need to give it a pre-running. It has to start to turn. So we have to inch it from this side through electrical means. And as you can see, the electric motor is so huge. This is the electric motor that keeps the drive in the engine drive of the ball mill before it can properly be started at the control room. Let's get on the other side for you to see certain aspects of the ball mill. Okay. Here we actually see that this outside part of the ball mill is known as the trommel screen. It's like a sheave point. This is where, after grinding, you get the smaller size materials to come here. They will be sheaved and sent down to the hopper, and the hopper that is underneath will now, through pump and pipe network, send to the hydrocyclone that I'll shortly show you. So basically, this is how the arrangement of the ball mill is being done. It's a grinding process that involves charging of media. That is basically, you can use ceramic balls or steel balls to keep rotating, and once they ride on top of each other, they will grind and reduce the size of the ore until we get some fine particles before being sent to the hydrocyclone. So in a short while, we'll get to the hydrocyclone. Thank you.